Mars, the red planet, a celestial neighbor that has captivated humanity for centuries. It beckons us with its rusty dunes, towering volcanoes, and the tantalizing possibility of life. But Mars presents a challenge. Its thin atmosphere, composed mostly of carbon dioxide, cannot sustain human life. To conquer Mars, we need oxygen. Oxygen to breathe. Oxygen to fuel our rockets for the journey home. Transporting enough oxygen from Earth is impractical and costly. We need a better way. MOXIE is a technological marvel. A miniature oxygen factory designed to thrive in the harsh Martian environment. Nestled aboard the Perseverance rover, MOXIE embarked on a groundbreaking mission to demonstrate that we can indeed extract oxygen from the thin Martian air. But how does it work? Picture a reverse fuel cell. Instead of consuming oxygen to generate electricity, MOXIE does the opposite. It uses electricity to split carbon dioxide molecules, the main ingredient in Martian air, into their constituent atoms, carbon and oxygen. This process, called electrolysis, takes place within a specialized chamber heated to extreme temperatures. Here, the carbon dioxide is coaxed into releasing its precious oxygen atoms. The result? Breathable oxygen ready to sustain human life and propel our rockets homeward. The process begins with MOXIE drawing in Martian air, a crucial first step in the journey from the thin Martian atmosphere to breathable oxygen. The Martian atmosphere, though thin and composed mostly of carbon dioxide, is an accessible resource that MOXIE can utilize. This air, primarily composed of carbon dioxide, is then filtered to remove any dust or impurities that might hinder the oxygen extraction process. The filtration is essential to ensure that the subsequent steps are not compromised by Martian dust, which can be pervasive and problematic. The purified carbon dioxide is then directed into a chamber known as the solid oxide electrolyzer, or SOx. Here, the magic happens. The SOx is a sophisticated piece of technology designed to handle the extreme conditions required for this transformation. The SOx, heated to a scorching 800 degrees Celsius, or 1,472 degrees Fahrenheit, acts as a catalyst for the transformation. This high temperature is necessary to facilitate the chemical reactions that will split the carbon dioxide molecules. Within the SOxy, an electric current flows through a ceramic material, splitting the carbon dioxide molecules into oxygen ions and carbon monoxide. The ceramic material is specially designed to withstand these high temperatures and conduct the electric current efficiently. The oxygen ions then migrate through the SOx, combining to form breathable oxygen gas. This migration is a critical step, as it ensures that the oxygen ions are properly collected and converted into a usable form. This oxygen is then analyzed for purity before being released back into the Martian atmosphere. The analysis is crucial to ensure that the oxygen produced is of high quality and free from contaminants. This entire process, from drawing in Martian air to releasing purified oxygen, represents a significant technological achievement and a step forward in our quest to make Mars a more habitable place for future explorers. Command: currently the VO is 135 words long, please expand it to be 340 words long. Section 4. MOXIE's First Breath, a Giant Leap for Humanity, April 20th, 2021. On this historic day, a new chapter in space exploration was written, one that would forever change our understanding of what is possible on the Red Planet. A day etched in the annals of space exploration. It was a moment that stood alongside the first moon landing and the launch of the Hubble Space Telescope, a testament to human ingenuity and perseverance. On that day, MOXIE took its first breath, successfully extracting oxygen from the Martian atmosphere. This was not just a technical achievement, but a profound leap forward in our quest to make Mars a second home for humanity. This groundbreaking achievement, broadcast live from millions of miles away, ignited imaginations and heralded a new era of possibilities. People around the world watched in awe as the tiny device on a distant planet performed a task that had only been dreamed of in science fiction. The first run, while modest in output, proved the concept. It was a small but significant step, showing that we could indeed produce oxygen on Mars, a critical resource for future human missions. MOXIE produced 5.4 grams of oxygen, enough to sustain an astronaut for roughly 10 minutes of normal activity. This may seem like a small amount, but it was a monumental proof of concept, demonstrating that we could create life-sustaining resources on another planet. While seemingly small, this achievement marked a pivotal step towards our long-term goal of establishing a sustainable human presence on Mars. It was a glimpse into a future where humans could live and work on the Martian surface using local resources to survive and thrive. This initial success sent shockwaves of excitement through the scientific community and beyond. It was a moment of validation for years of hard work and dedication, a clear signal that we were on the right path. It demonstrated unequivocally that we can harness the resources of another planet to sustain human life. This capability is crucial for the future of space exploration, as it reduces our dependence on Earth and opens up new possibilities for long-term missions. It was a triumph of human ingenuity, a testament to our unwavering spirit of exploration. The success of MOXIE is a reminder that with determination, creativity, and collaboration, we can overcome the most daunting challenges and achieve the seemingly impossible. As we look to the future, the success of MOXIE serves as a foundation for more ambitious endeavors. It paves the way for larger-scale oxygen production systems, which will be essential for supporting human colonies on Mars. Imagine a future where humans live and work on Mars, breathing air produced by machines like MOXIE. This vision is no longer a distant dream, but a tangible goal within our reach. The journey to Mars is filled with challenges, but each success brings us one step closer to making it a reality. MOXIE's first breath is just the beginning of a new era in space exploration, one that promises to transform our understanding of the universe and our place within it. As we celebrate this milestone, we are reminded of the power of human innovation and the endless possibilities that lie ahead. The story of MOXIE is a story of hope, determination, and the relentless pursuit of knowledge. It is a giant leap for humanity, and the first of many steps towards a future where Mars is not just a distant planet, but a new frontier for human exploration and settlement. Section 5, Experimentation and Optimization, the Road to Success. The success of MOXIE's first run was just the beginning. It marked a significant milestone in our journey towards sustainable human presence on Mars. The initial success was a testament to the hard work, dedication, and innovative spirit of the entire team. Since then, MOXIE has undergone a series of experimental runs, each one meticulously planned and executed to test its limits, optimize its performance, and refine our understanding of its capabilities. These runs are not just about producing oxygen, they are about pushing the boundaries of what is possible. These experiments have involved varying the duration of the oxygen production runs, sometimes running MOXIE for extended periods to see how it performs under continuous operation. This helps us understand the long-term viability of the technology. Adjusting the operating temperature and pressure within the SOx has been crucial. By experimenting with different settings, we can determine the optimal conditions for oxygen production, ensuring that MOXIE operates efficiently and reliably in the harsh Martian environment. Analyzing the purity and composition of the produced oxygen under different conditions is another critical aspect. This ensures that the oxygen generated is safe for human use and meets the necessary standards for future missions. Each run has provided valuable data, allowing engineers and scientists back on Earth to fine-tune MOXIE's performance. This data is meticulously analyzed, leading to insights that drive further improvements and innovations. This iterative process of experimentation and optimization is the hallmark of successful engineering. It is through this relentless pursuit of perfection that we make incremental advancements, each one bringing us closer to our ultimate goal. It's through this rigorous testing and refinement that we learn, adapt, and ultimately achieve our goals. The process is challenging, but it is also incredibly rewarding, as each improvement brings us one step closer to making human life on Mars a reality. And with each successful run, MOXIE moves us closer to our dream of a human future on Mars. The progress we make today lays the foundation for the missions of tomorrow, inspiring hope and excitement for what lies ahead. The road to success is long and arduous, but with perseverance and innovation, we are paving the way for a new era of exploration and discovery.